with triangles. And what we're going to be doing is we're going to take previous and prior information from Chapter 9, Lesson 1, in which you were looking for the area of a parallelogram. And in that lesson, for the area of a parallelogram, you used base times height. Now, why do we need, or why would we want to know about that formula in regards to finding the area of a triangle? Because our formula here says that in order for us to find the area of a triangle, we use half of the base times the height. These formulas will start to get really convoluted because you're trying to remember which formula is for what shape. But I'm going to say that it is important to know the foundational formula for area of a parallelogram, because that's what starts everything. Literally, you use part of it in almost all of the formulas. Remember how before you had the shape of a rectangle? On yesterday's lesson, you were doing this, where you were looking for base times the height. Hopefully this is ringing a bell. And all you do is multiply these two numbers for yesterday's lesson. This was a rectangle shape. Well, if you think about it, if you divide this parallelogram in half, you get two triangles, don't you? Well, that's what's happening here. When I divide my parallelogram in half, now I have two triangles. And the answer would literally be base times your height. Remember how we look for this little red square? It literally touches the two sides that I need in order to find the base times the height. This square, this little hand here is touching this line, and that's the base. Whatever number that would be, I would plug under the letter B. Now look at the other. Let's pretend this is a hand. It's touching this side. Well, whatever number the height is, I plug underneath here. Let's begin. They didn't give you any numbers, you notice, but I can figure this out just by counting the units here. So I'm going to try the base first. And base could be either top or bottom, it won't matter, but here we have the base down below here. And we're going to count 1, 2, 3, 4, 5, 6. I still count this one. You're not worried that it's not filled in because you're looking at the line from start to finish, and it ends here. So yes, we count 1, 2, 3, 4, 5, 6. So 6 is our base. Write that right underneath. Yes, you do write your formula. You always write that first. I'm going to write my fraction here. A half times 6. Now I'm going to look for my height. Well, again, it's touching the other side, my little square. I'm going to count 1, 2, 3, 4. So it's going to be multiplied. Underneath, I'm going to plug the 4. Now, I'm going to solve. I'm going to solve what I know. I can do 6 times 4, or I could do half of the 6, which would give me 3, and then I can multiply it by 4. It doesn't really matter since it's all being multiplied. So when all of the numbers are being multiplied, it doesn't matter which way you begin. But let's start left to right. Sometimes I'm going to want to start left to right. Sometimes I want to do this because it's easier. It doesn't really matter. Half of 6 is 3. Bring everything down that you didn't use. I didn't use my multiplication sign. I didn't use my 4. I already used the half when I did half times 6. Half of 6, sorry. Or half times 6, literally. And then, now I'm going to multiply. It's my last step. 3 times 4 is 12. And I have 12. Now I need a label. That's step 4. Remember, it doesn't have a label because these are units. And we talked about the units here when I was speaking about the triangle originally. These are units, so it's going to be square units. So the area of this triangle is 12 square units. Now, you could have literally gone, well, can I just count them up? Let's count the full ones first. 1, this is kind of full, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you start to add some of these in here, like this little piece can go up here, that give you 11. And then this little piece right there can go up there to fill in this little spot here. That would give you 12. So you've got 12 square units here.